Hi guys and girls, video here just on the introduction of logarithms, how to write them, what they kind of mean, how the graphs look, and how to do a few calculations with them as well. Right, let's start with how to write them and kind of what they mean. So a logarithm is made up of kind of three parts. So you've got the word log, short for logarithm, obviously, and you've got a base. So you might have base, let's call it B for base. Now that could be, any number. There's no restriction on what your base could be. All it is like whether you're working in powers of 2 or 10 or whatever. It's to do with powers. And then you've got the number that you are finding the logarithm of. So I'm going to call that A. And then once you do that calculation, you will get an answer. Maybe I should have written A and C the other way around. So the thing you are calculating the logarithm of and the answer you will get. That makes a bit more sense. So what that is actually asking you is, if I'm working in powers of whatever your base is, what power will give me the answer of the thing I'm trying to log? For example, log to base 2 of 8 would be 2 to the power of what gives me 8? Well, we know 2 to the power of 3 gives us 8, so my answer would be 3. Similarly, log to base 10 of 100, sorry, means using base 10, what power of that would give me 100? Well, we know that's squared, so my answer would be 2. Right, so they are a kind of weird way of writing powers. And there's a few other rules and other things, bits and bobs as well. So one of those, or you have to remember this top bit, you do have to remember that is not given in any formula books. The couple of, not restrictions, but weird things. If you ever see log written without a base, that has an assumed base of log 10. So if you just see the word log, that is the same as log base 10. All right, pretty much everything in the first part of an A level will be written as log, and oh dear, don't do that. She doesn't understand something. Go away. Lost my train of thought. Oh yeah, there's another one. You tend to see this one a bit more in A2, or the second part of your A-level course, depending on what you call your A-level course. That's this one. It's an L and an N. So we say it as ln. It's actually the natural logarithm. And that is log to base e. Now, if you haven't come across e yet, e is just a number. A bit like pi is just a number. It's an irrational number. It's a little bit more than 2. And you can go away and research kind of what it is and all that kind of stuff if you like. For now, all you need to know is that ln is log base e. Alright, so they're the only kind of two exceptions on how you write it. You wouldn't be marked down if you wrote log base e or log base 10, but it's more that your exercise books or your test papers will not write it that way. They will write it as just log or ln. It's something to be aware of. Hokey cokey. Let's get into some actual. Actually, no, I want to show you the graphs first, so you can kind of relate the two. So if we are doing, 2 to the power of whatever, 2 to the power of x values, there we go, that's the word I want. Its graph, and any exponential graph, will look like that. This value here is always 1, and there is an asymptote. You remember what asymptotes are? Always unsure as to whether it's got two S's or one. That looks right. An asymptote is a graph, or sorry, an area or particular number on your graph where it is undefined. So the function doesn't exist at that particular point. If you imagine a tan graph, every odd 90, it kind of goes up, and then you have those dotted lines that come down, and then the graph starts again, and goes up, and then dot lines. Those dotted lines are asymptotes. And on here, your dotted line is actually across the x-axis. For a logarithm, we've kind of, I've kind of mentioned that it's the inverse to powers. So it's the inverse to this line, it's the inverse function. And anytime you're trying to graph an inverse function, you reflect the curve you already have in the line y equals x. So you'll end up with an asymptote, instead of being on the x-axis, will be along the y-axis. It's not a very straight line. And instead of curving up to infinity, it will curve positively, horizontally, whatever you like, off to infinity that way instead. All right, so it will have an asymptote on the y-axis for a log. So that's what they look like. Any logarithm will look like that. It's just the bigger the base, the steeper the curves are, so it will go to infinity quicker. Right, let's get on to some calculations then. So I've got 6 things for you. A few of them are just manipulations and evaluations, and then we'll get into kind of like your first rule, really. It's not really a rule, but yeah. Let's go. So first one I've got for you is an evaluate. So I've got 3 evaluates to do. Ooh, that's awful. There we go. So the first one is log to base 25 of 5. Now we've kind of seen right at the beginning that that means 25 to the power of what gives me 5. Well, 5 is the square root of 25, and if I wanted to write square root as a power, that would have to be half. So the answer to this is a half. The second one I've got for you is ln, remember that's log to base e, of e to the 7. So that means e to the power of what gives me e to the 7. Well, that's pretty straightforward. That's got to be 7, because e to the 7 equals e to the 7. Okay, last evaluate one. Now this one's a bit more complicated. Well, it's not really that complicated. 10 to the power of 3 plus log 4. So this is kind of one of the first rules is going to come in. All right. First thing you need to do isn't a log rule, it is an index rule. So if you have a plus in your power, you will have a multiply when you bring it out of the power. There we go. Now, first bit we know is 1,000. The first kind of rule is that if the base of the logarithm and the power you are finding it of, I guess, are the same, they will cancel each other out. So log to base 10 and 10 cancel out. Then the 4 will just drop down. Right? And it works either way around. So if you've got log to base 10 of 10, those will cancel out to leave you with 1. Now that one will make a bit more sense if I do it this way. So log to base 10 of 10, if I was to get rid of get rid of it? Nearly. Is 10 to the power of what gives me 10? Well, that has to be a 1. Right, so they cancel each other out. Anyway, so the answer there is 4,000. So remember, if your base power is the same as the base of your logarithm, they cancel. Right, let's go on to the next one. So these ones are manipulations, more manipulations of. I've got 2 that are making the subject or changing the subject, and 1 that is a solve an algebraic equation. Right, let's start with. So make x the subject of. And the first one I've got for you is log the base 3 of x is equal to y plus 2. So I need to come up with a way of getting rid of that log. Well, we've just seen that if I have the base and the logarithmic base the same, they will cancel out. So I often refer to this as raise it. I know a lot of other teachers do. There's not really a proper name for it. It basically means put the base that you want the power in. So if I want to cancel out a log base 3, I would put log to the power of log base 3. As long as I do that on the other side, that's mathematically fine. So then the log base 3, log base 3 and 3 will cancel out. The x will drop down, and 3 to the power of y plus 2. There we go, done. We've got rid of it. We've got x on its own. X is now the subject. Problem solved. The next one, B. Same thing, make x the subject. This one is log to base x of y plus 2 again is equal to 1. Now, the x is in a really weird place here, but the only option I've got is to raise it. There's nothing else I can do. So, if we raise it, I get x to log base x of y plus 2 is equal to x to the 1. Well, the log and the x cancel from this side. This drops down. Gives me x. Well, x to the 1 is just x. Done. X is the subject. And the last one I've got for you is a solve. Alright, so solve 2 ln 3 plus x is equal to 8. Well, the first thing to say is you can't raise it if there's things in front of the ln or the log. So I'm going to divide by 2 to leave me with ln 3 plus x is equal to 4. Now I can raise it. Ln is log base e, so I'm going to do e to the power of ln and e to the power of 4. So the ln and the e cancel out, the x plus 3 drops down, and e to the 4 stays as it is. The next thing then is to take away 3 from both sides to leave us with x equals 4 e to the 4 minus 3. Now, that kind of feels a little unnatural to say that that is the answer because we're so used to letters being variables. But remember, e is just a number, like pi.